Okay, what I want to talk about in this video is in chapter 3, but we want to talk about chapter 3 we were talking about how stresses and strains are related through material properties, and we talked about how stress is related to strain in tension, right? We talked about the tensile test, and that gave us Hooke's law, and then we also had, so that relates to normal stress to normal strain, and then there was this other mechanism of Poisson effect. Sorry. So in this video, we want to talk about not how the normal stress and the normal strains are related, but how the shear stresses and the shear strains are related. Okay? And it turns out they're analogous. It's a linear elastic relationship. Shear stress and shear strain. Okay. So a smaller book. Okay. All right. Let's imagine that this book is a block of material. And although it's pretty poorly formed, initially imagine this is a rectangle. Okay? Now, to apply a shear load onto this block, let's basically put a force on the bottom edge in the negative x direction, and then a force on the top edge in the positive x direction. And what happens is, the whole thing should rotate, but you see what happens is, it turns into a trapezoid. Okay, so what are originally 90-degree angles to the top and bottom surfaces and sides, right? We have a 90-degree angle in here. We've got initial 90-degree angle. Now we shear it, and that 90-degree angle changes angle, right? So now this angle here is that is the shear strain angle, right? That is the shear strain angle. Okay? Now, we're supposed to try to do this so that the top and bottom pages, the covers, whatever you want to call it, remain in a straight line. And that's what happens. So that's the shear effect. So I'm putting a force on here, V, right? V, okay? So V divided by the surface area that it's applied on, that's the area of the top of the book, gives me a shear stress. V over A. That's the shear stress. Now, do it. Then look across the pages of the book. Now you see that shear strain angle. Okay? This gives us gain. Okay? So shear stress gives purely a shear strain. So initially, it looks like this. And once it deforms, it takes the following configuration, right? This angle here is the shear strain angle gamma, shear strain gamma. What you notice is there is no Poisson effect, or nothing happens in the opposite dimension. When you put shear stress on, you only get the shear strain, and they are related in an analogous manner to Hooke's law. So what you find is shear stress is related to the shear strain through a material constant call this material constant. Well, the book calls it the modulus of rigidity. It's more popular in civil engineering. But it's also called, I should call it shear modulus. Okay? Modulus of rigidity, shear modulus. Okay? If you look at, recall Hooke's law, the normal stress is related to the normal strain through Young's modulus. You can see these things, you can see them now, right? Here's the strain, here's the stress on the left side, and they're related through a material constant. Okay? Now again, the units for stress and strain are the same in normal and shear, so the units of G, the modulus of rigidity, are going to be stress units, just like Young's modulus. PSI, Pascal, gigapascals, so on and so forth. Okay? Okay. So again, the way the problems typically go, maybe you're given geometry, so you're given V, and then the area that V acts on, the area of the book base, right? Cover. So then you can figure out the shear stress. You can look up in the last page of the text, and you can find G for most materials. For example, it's typically about a third of Young's modulus, and then from that you can determine the shear strain, or if you're given the shear strain, you can determine the shear stress, or if you're given the shear strain and the shear stress, like if it were a material test, you could then determine the shear modulus of the modulus of rigidity. Okay? And that's the way it works. So you can think of it just like Hooke's law, it's a linear elastic homogeneous relationship. It's the simplest relationship you can have. You can get plasticity effects and those sorts of things. They go the sort of the same way, but we really won't cover that in this class per se. Okay? So that's all I really want to talk about in regards to the shear material